Hello everyone, Jai Hind to all. Welcome in digital studio of Ajay Kumar Garg Engineering College, Ghaziabad. In this video lecture, I am going to discuss about regular expression and regular language. We also discuss how the regular expression is converted into DFA. This is the outline of the lecture: definition of regular expression, definition of regular language, operation or regular language, example of regular expression, fundamentals of regular expression and finite automata, and then we have to discuss about question. In question, we have to discuss how a regular expression is converted into DFA. This is the definition of regular expression. What is mean by regular expression? The language accepted by finite automata can be easily described by a simple expression called a regular expression. It is most effective way to represent any language. Language means a set of string is called language, and that language how to represent in the form of regular expression. That regular expression is represented by a DFA or a finite automata. Second point is, a regular expression can be also be described as a sequence of pattern that define a string. That means a string which is written in the form of input symbol, that can be also written in the form of a regular expression. Regular expressions are used to match character combination in string. String searching algorithm used for this pattern to find the operation on a string. This is the basic concepts which is used to implement language into the form of regular expression, and then regular expression is converted into the given diagram. This is the definition of regular language. What is mean by regular language? Regular language means if a language generated by a regular grammar, then the language is called regular language, and this regular language is accepted by a deterministic finite automata. This is the most simple and effective machine which is used to process the language of the form of a regular. The language accepted by some regular expression are refers to as regular language. That means if a regular expression and we have to write the regular expression in the form of symbol, then expression is called regular language. There are some operations on regular expression. That means if we have the given regular expression, then what is mean by union, what is the intersection, what is the concatenation, and how this operation to be performed on the given set of language. Here, if L and M are two regular language, that means L is a regular language and M is the another regular language, then the union of this language is written as L union M is also a union. That means is also a regular language. If we have two regular language L and M and we take union of both the language, then the language generated by union of L and M is also a regular language. Next point is intersection. Intersection means if L and M are two regular language, then their intersection is also an intersection. That means if L and M are two regular language and we have to perform intersection between L and M, then the language generated by this intersection is also a regular language. Next point is knee closure. If L is the regular language, then its knee closure is written like L power steric. This is the example of knee closure. Now, if L1 is a language, then the knee closure of L1 is written like L1 steric, and L1 is a regular language, then L1 steric is also a regular language. This is the basic concepts of knee closure. Now, concatenation of two language. If we have two language L1 and L2 and we perform concatenation of these two language written like L1 dot L2 and L1 dot L2 will also be a regular expression or a regular language. Now, next point is complement. The complement of language L is written like L dash of G. L dash of G means, and LG means the language generated by the given grammar is written as LG, and L dash G is called the language of the language complement of LG is written as L dash G will also be a regular language. Complement can be a language found by subtracting string which is in LG from all possible string. That means I have number of string and that is the written like this in the form of set. Then we want to find L dash G, then we have to subtract L dash from the given language. We obtained L dash of the given language. That means the language which is covered in L is not be the part of L dash G. L dash G contain the rest part of LG. The next point is example of regular expression. Here we have taken an example. Write the regular expression for the language accepting all the string which are starting with 1 and ending with 0. That means the set of all strings of zeros and ones that start with 1 and end with 0. First, we have to write set of all string of zeros and ones, and the regular language for set of all string of zeros and ones is 0 plus 1 steric. Now, the condition is the string start with 1 and end with 0. So, we have to take 1 at the initial of the regular language and this string end with 0. So, we have to write 0 at last. This is the regular language for the example number 1. Our regular expression for the given example. Now, the second example is example number 2. Write the regular expression for the language starting and ending with A and having any combination of V's in between. That means this is the string of symbols A and B. Any number of B, that means B steric gives any number of B and the string start with A. So, we have to write A as an initial symbol. Then the number of B is not fixed, any number of B. So, we have to write B steric and the string end with B. So, we have to write B at the last of the expression, and this is the solution of example number 2. This is the two basic questions in which we have to construct a regular expression for the given statement. The main part of this is if the sentence like this, all the strings, then we have to take 0 plus 1 steric, all the string of A and B, we have to take A plus B steric, all the strings of C and D, then we have to take C plus D steric. Then we have to implement the starting and initial condition of regular expression. Here the initial condition is the string start with 1, so we have to take 1 as a starting symbol and the string end with 0, so we have to take 0 at the last position. And such on, we have to write the regular expression for the given statement or given conditions. Now we have to going to convert a given regular expression into finite automata. Before converting the regular expression into finite automata, first we want to discuss what is the basic or what is the fundamentals which is used to convert the given regular expression into finite automata. There are some fundamentals. The first fundamentals is r equal to pi. This r equal to pi is called null expression, and how the null expression is represent in a finite automata form or in the form of diagram. Let us see. Here the expression is r is equal to pi or r is equal to null. We have to take a state that is called qf, and the qf means it is the final state, and in automata the final state is represented by double circle, and we mark this state as a entering arrow, and the entering arrow is show the initial state. So this is the diagram of r equal to pi. We take a state qf that is marked as a final state, and then we mark initial state also, and this represent r equal to pi for a finite automata representation. Now r equal to phi. For r equal to phi, we have to take a initial state q naught, then we have to take a final state qf and mark as a final. Q naught is marked as initial. This is the differentiation between initial state and final state. Final state marked as qf and initial state is marked as q naught, and a arrow is qf to q naught. This represent r equal to phi. Now the next regular expression is r is equal to a. The basic concept like r equal to phi, initially we have to take a initial state q naught, a final state qf. Q naught is marked as initial state, and a directional edge from q naught to qf, and this edge marking is a. This is called r equal to a. Initial state q naught, a final state qf, mark as the final state by double circle, mark as entering arrow for initial state, and a directional edge from q naught to qf, and the level of this edge is a. This is the diagram of r equal to a. Now the next expression is r equal to a plus b. First we have take a initial state q naught, mark entering arrow, then we have to take a final state qf, mark as double circle, and the directional edge q naught to qf, and the edge marking is a plus b. Now we want to remove this plus. How to remove this plus? We have to take same state q naught as initial, qf as final, and one edge for a and another edge for b. This is the diagram of r equal to a plus b. We have to split edge for one for a and another for b. We can also represent this diagram like this: state q naught, initial state q naught, final state qf, a directional edge q naught to qf, and here we have to mark a comma b. This is the similar to this diagram. There is no difference between the two diagrams, but by the clarity or by the better understanding, we have to take this diagram as a preference. Now the next one is r equal to a dot b. First we have to take a initial state q naught, a final state qf, and a directional edge q naught to qf, and here is a dot b. Now we have to remove dot between a and b. So we have to take Q naught as an initial state, QF as a final state, and there is also a next state between Q naught and QF. Here Q naught to Q1, here Q1 to QF. Q naught is initial state, we mark entering arrow, here A and here B. This is the diagram of R equal to A dot B. That means dot is removed by entering a new state between A and B, and we have to attach the given state in a sequentially. Q naught to Q1 A, Q1 to QF B, and this is the diagram of A dot B dot C. If you have the A dot B dot C, then we have to draw like this: Q naught, Q1, Q2 and QF. QF is the final. Here the direction of arrow. This is the initial state. Here A, here B and here C. This is the finite automata of R equal to A dot B dot C. This is the another example. R equal to A dot B dot C. Now the next is R equal to A steric. First we have to take same as previous case, Q naught initial state, QF final state, and here a directional edge, and we mark at A steric. Now we have to take a state between them, Q naught, we take Q1 the next state, then QF as it is, here null, and here the self loop of A. This is the diagram of R equal to A star. So this is the basic concepts to represent the diagram of the given regular expression or the finite automata for the given irregular expression. This is the Q naught QF between marking of this edge is A star. Then we have to take a new state between Q naught and QF and a self loop of A, and before Q1 the marking of edge is null, and after Q1 the marking of null edge is null. Now we take a example. The example is 0 plus 1 steric, 0 0 plus 1 1, then bracket 1 plus 0 steric. We want to convert this regular expression into DFA, deterministic finite automata. By using the fundamental or basic concepts, we have to convert this expression into DFA. We discussed earlier how the plus is solved, how the dot is solved, or how the steric is solved. By using these concepts, we have to convert the given expression into DFA. First, we want to draw the first steps of this regular expression. We take a initial state Q naught, a final state QF, like this. This is the initial state, so we have to mark entering arrow. Now a directional edge Q naught to QF, and here we have to mark 0 plus 1 steric, bracket 0 plus 0, bracket 1 plus 1, bracket 0 plus 1 steric. This is the whole expression which is given in the question. We take an initial state Q naught, a final state QF, and write the whole string on the edge of Q naught to QF. Now we want to solve this expression one by one. Here first we have to solve dot operator. That means this is treated like A, this is treated like B, and this is like C. We have to remove the dot operator between this expression, and we have to write like this: Q naught initial state, then Q1, then Q2, then QF. We have to take Q3 or Q4 at the place of Q4F. We take according to the need. Now, a directional edge Q0 to Q1 and the marking of edge is 0 plus 1 steric. A directional edge Q1 to Q2 marking is 0 plus 0 0 plus 1 1, and here 0 plus 1 steric. We solve the dot operator. We mark 0 plus 1 steric, then 0 0 plus 1 1, then 0 plus 1 steric. Now, we want to solve star from here, plus from here, and star from here. By using the basic concepts of star, we have to solve the given diagram. We take a state between this here and mark null on both sides, a self loop of 0 plus 1. Here we construct two loop, one for 0 0 and one for 1 1, and here is also we take a state Q4 and mark null on both sides and a self loop of 0 plus 1. The next diagram of this step is this. Here we have to take a state Q0. This is the initial state. This is the Q3 which is taken between Q1 and Q2 and a self loop of 0 plus 1. Here we not change the 0 0 plus 1 1. We have to take it as a combined. If we want to change, we have to take 1 for 0 0 and 1 for 1 1, and same condition for last of the string, because these 1 plus 0 plus 1 steric and 0 plus 1 steric both are the similar. Now we have to remove plus. How to remove plus? One is for 0 and one is for 1. Same here also, one is for 0 and one is for 1. Here we have to remove plus, and plus is solved like this. There are two h, one for 0 0 and another for 1 1. Here 0 is individual, 1 is individual, 0 is individual, 1 is individual. Here 0.0 and 1.1. We want to solve here 0.0 and here 1.1. How we solve 0.0 and 1.1? We take a state Q5, one side mark as 0 and then go on Q2, another side also mark as 0. Here 1 1 is, this is solved the 0 0. Here 1 1 is solved like this. We take a state Q6, one side 1 and another side 1. This is the final diagram of the given regular expression. This is the Q0 null, Q3, Q1 here 0 0 1 1, Q2 null, 1 for 0 1 for 1 null, and QF. This is the final diagram of the given regular expression. This is called finite automata. But in the given question, we have to convert the given regular expression into DFA. So we have to first remove the null from the given diagram. How the null is removed? Null is removed like this. If there is a state Q1, here the null marking, and here Q2, and this is the final state, here a loop of 0, then we have to combine the property of both the state. Here if the loop of 1, then by combining this state, we have to write, we take Q1 as a state or Q2 as a state, we take any of 1. Here we take Q1 as a state, Q1 is the this and contains self loop of 1, null is removed, then Q2 is a final, so Q1 is also final, and the loop of Q2 is coincide with Q1. This is the final diagram after removing the null. That is called superposition method, in which we have to combine the state of the state which is connected with null, and the property of both the state on a single state. And here we show how the state is combined. This is the final diagram after removing the null. Q0, Q3, in between Q0 and Q3 there is a null which is removed. Q3 and Q1 is also a null which is also removed, and we take state Q0. You can take any state that depend on you. Here we take Q0, here we take Q5, here Q6, here is QF, and the self loop is 0 and 1. This is the diagram after removing the null from the given finite automata. Now, we convert this diagram into DFA, because for a single input 0, the next state is Q0. On the state Q0 input 0, the next state is Q0. For 0, the next state is Q0, and for 0, the next state is QF, Q5. That means for a single input, there are more than one next state. So, this diagram is NFA, and we want to convert DFA. So, by using any method which is used to convert NFA into DFA, we have to convert the given diagram into DFA, but here we have to use table method. In table method, first we have to construct the table for the this diagram. There are 4 states Q0, Q5, Q6 and QF. This state is, firstly we have to write in first column Q0, Q5, Q6 and QF, and for 0, for at state Q0 input 0, the next state is Q0, Q5. So, we have to write for input 0, the next state is Q0 and Q5. So, we have to write here Q0 comma Q0, Q5. Here we have to write Q0 comma Q6. This is for input 1. Here QF, here there is no next state, so we have to mark as dash. Here on state Q6 input 0, there is no next state, so we have to mark dash, and at state Q6 for input 1, the next state is Q6, so QF, so we have to write here Q6, and so on. QF input 0, QF input 1, QF. Now we have to going to combine this state by using bracket method. First we have to take Q0 is a initial state and QF is a final state. In table, entering arrow is also show the initial state and circle is shown by final state. And initial and final state we mark only in the column of table. There is no need to mark in the input section. We have to only mark on the set of states. That is called first column. Q0 initial state, so you have to mark entering arrow, and QF is the final state, so you have to mark as a circle. Now we use bracket. First we have to start with initial state and write like this: bracket Q0, then bracket Q0 Q5, then bracket Q0 Q6. We have to use bracket in the row of initial state like this: Q0, Q0, Q5, Q0 and Q6. In the next step, now we take all the next state, the entry of next state in first column. Here there are 2 new state, Q0 and Q5 and Q0 and Q6. This state written in first column. So we have to write here, first we have to write Q0 rows, and then we copy the input 0 and 1 next state for input 0 and 1. Here the Q0 and Q5. So we have to write here Q0 and Q5. Now by the help of previous table, we have to combine Q0 and Q5 for entry 0 and for entry 1. For entry 0, Q0, Q5, QF. So we have to write here Q0, Q5 and QF. For entry 1, after combining the Q0 and Q5, the state is Q0 and Q6. So we have to write here Q0 and Q6. Now the next state is Q0 and Q6. We have to write here Q0, Q6. Now we have to combine Q0 with Q6, Q0 with Q6 for entry 0, here dash Q0, Q5. So we have to write here Q0, Q5. For entry 1, Q0, Q6 and QF. So we have to write here Q0, Q6 and QF. Now, this state is on the first column. This state is also on first column. A new state is gives, that is Q0, Q5 and Q6. So we have to write here Q0, Q5 and QF. And now we have to combine Q0, Q5 and Q6. Combining for 0, combining for 1. The next state is Q0, Q5, Q6, QF, Q0, Q6 and QF. The next new state is Q0 and Q6, also written in first column. The new state is Q0, Q6 and QF, that state written in first column. And now we have to combine Q0, Q6 and QF for entry 0 and 1. And this is the entry for input 0 and 1. This is the final table of DFA, but we want to show this table in the form of diagram. So we have to construct diagram for the given table. How the diagram is constructed? First, we have to take 5 states: state 1, state 2, state 3, state 4 and state 5. State Q0 is marked as the initial state, and the state which contain the final state is marked as the double circle for the final state. Here QF, so its state marked is circle and this is also a circle. Final state more than one, but initial state must be a single. That is the basic concepts of automata. Now this is the diagram of the given or the given table. Here we have take initial state Q0, here Q0, Q5, here Q0, Q6, here Q0, Q5, Q6, QF, Q0, Q6 and QF. For input 0, we have to take a single state Q0, input 0, the next state is Q0. This comes from here, Q0 input 0, the next state is Q0, Q5, Q0 input 1, the next state is Q0, Q6. So we have to write for input 1, Q0, Q6 and for input 0, Q0, Q5. Now we have to check Q0, Q5 for input 0 and 1 and Q0, Q6 for input 0 and 1. Go on table, we have to check Q0, Q5 for input 0. We take a single state. That means we have to take a Q5 and check for 0. Q5 input 0, the next state is Q0, Q5, QF. So for input 0, Q0, Q5 and QF. For input 1, Q0 and Q6. For input 1, Q0 and Q6. So we have to connect Q0, Q5 to Q0, Q6. Now check Q0, Q6 for input 0, that is Q0, Q5 and input 1, Q0, Q2, Q6 and QF. Now we have to check both state for 0 and 1, Q0, Q5 and QF for input 0 and 1. For input 0, there is a self loop. That means in table for input 0, the same state is gives Q0, Q0, Q5 and QF. For input 1, Q0, Q6 and QF. So we have to connect for input 1, Q0, Q6 and QF for input 0, Q0, Q5, QF and for input 1, the self loop. This is the initial state, so we have to mark entering array, and this state is content QF, so we have to mark final state by double circle. In diagram, double circle show the final state. In table, single circle show the final state. And entering arrow in the both case are the same. Table, we have to also mark the entering arrow for initial state, and in diagram, we have to also mark entering arrow as a initial state. This is the final DFA for the given regular expression. This is the all about the regular expression. If any doubts, we have to check regularly, and if you give the comment in the comment box, I am very thankful. Thank you so much.